Welcome back to our channel ClassFly community. So today is the lecture 10, that is the revision of the module 5. Without wasting more time, let's begin. So today the first thing is that the failures of classical free electron theory. So there were basically three failures. First of all is the prediction of the low specific heat for metals. Second is the temperature dependence of electrical conductivity. Third is the dependence of electrical conductivity on electron concentration. Then we will move coming to the Hall effect. Basically, Hall effect, you need to remember that there are two types of conductors like p type and n type, which has more electrons have more, in which holes are more. You need to remember all of that. The main thing is that whenever an electric field gets applied in a conductor, and in that conductor whenever an electric current is flowing perpendicular to that applied magnetic field, at that point of time a potential difference gets created across the conductor, and that phenomenon is known as Hall effect. And Hall effect was created or has been discovered by the scientist Edwin Hall. Now whenever we see the expression for Hall coefficient, we remember that Hall field basically is what? Hall voltage. That means that voltage which is occurring on the conductor, across the conductor. So that is only known as Hall voltage, or you can say Hall field. So whenever that Hall field is directly proportional to current density, how it is directly proportional to current density? As J is equal to I by R, as Hall voltage is equal to current, that's why current density also it is proportional with, and magnetic field. So the coefficient, Hall coefficient expression is RH is equal to EH by JB, where RH is the Hall effect, EH is the electric one, and JB is the one is current density, other is magnetic field. EH is the Hall field, or we can say Hall voltage. Okay. So next is our revision for the, now what is dipole? So two equal and opposite charge, when it gets separated and constitute as a dipole. So when dielectrics are together, you will see, so whenever an electric field is applied, you will see there is a small distance which created between two equal and opposite charges. So that is known as dipole. Now next come is polarization. When does polarization happen? The separation of effective center of positive and negative charge in a substances by the application of electric field is known as polarization. So this dipole when gets created, and due to that when the electric field gets applied, that's why it gets created. So that is basically known as polarization. Next is Clausius-Mosotty relation. So basically Clausius-Mosotty relation is the ratio between the microscopic property polarizability, which is denoted as alpha, to the macroscopic property, which is denoted as dielectric constant, which is epsilon r. So basically the Clausius relation is epsilon r minus 1 by epsilon r plus 2 is equal to n alpha by 3 epsilon naught, which we have already derived in our lectures. So you have seen this was the relation. Now mathematical expression of Hall effect is your VH is equal to IB by QND, where VH is the voltage, or you can say Hall field, I is the current, B is the magnetic field strength, Q is the charge, N is the number of carrier charges, D is the D we know it as we know it as thickness, right? So it's the thickness. So if we want a high level of voltage, so at that time we need a very thin layer of material, so that there is a occurrence of very high voltage and also very few mobility charges. Okay. Now the last is the conductivity expression. So we have derived a conductivity expression with that help of that I is equal to NEEAD, that formula. So or you can say I is equal to NE AVD, that means when the current is really has a relationship with drift velocity, by which we have derived a equation for the conductivity expression. So basically the expression is sigma is equal to E bracket NE mu E plus NH mu H, where NE is the number of electron, mu H is the mobility of the electrons, NH is the number of holes, mu H is the mobility of the holes, and E is the charge of the electron. Okay. So This is a very brief revision of the module 5. The important things I have only covered. So if you need a detailed description, you can see all the lectures. Till then, be happy and have a great day. And if you have any queries, please comment us down below. Thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.